we're going to be talking about object today. What is an object? What is a thing? Turns out nobody in the last 10,000 years has ever figured out what a thing is. And you say, well, what do you mean? That's a simple word. It's like, we all know what a thing is, don't we? Thank you. And no, the issue is that no one ever realized what a thing is, especially the mathematical physicists. And part of that has to do with the fact that a mathematician who calls himself, I thought he was letting me know about something. We have to define this word because physics is about objects. You can't do physics without objects. Mathematical physicists never had to do that because what they do is not physics. They call themselves mathematical physicists, but the physicist part is too much, really. It should stay with mathematicians. That's all they are. And a mathematician has no use for objects, for things. He can represent them with a number, which is what they do, and that's what they put in an equation. So they had no use whatsoever for objects. They can't put the word elephant in an equation. They can't put the word cube in an equation. So what they do, they represent it mathematically, whether it's a thing, length, width, and height, and they just take the measurements, or they use the mass, or how much time, or whatever this thing moved in, and that's what they're going to put in an equation. So they have no use for objects, and because they have no use for objects, all these years they thought that maybe they could figure out how this universe works on the basis of mathematics, that an equation is going to give them, for example, the grand unified theory, or the theory of everything. And, the reality is there are no theories in mathematics. They call them theories, but the word is misleading because a theory is an explanation, and an equation, or whatever the mathematicians do, doesn't explain anything. You cannot explain with an equation. It's just a description. And what's the problem there? Well, the problem is that for 10,000 years, no one has defined the word object. And so I realized that, that's the first thing I had to do. And when the issue here is that, I come up with a rope model of light and gravity. I can explain what you would call the gut or the toe, the grand unified theory, the fact that in one mechanism, you can produce light and gravity, which is the rope. At the same time that it holds two atoms together, right? You have a torsion going through that rope, and you can explain light. So with one mechanism, you have what you could call the grand unified theory, because this is a theory. It's an explanation for gravity and for light, for both. Okay, so that is a theory. But these people are looking for an equation, which even if they find it someday, which they never will, all they have is a description. Okay, so that's the problem. Okay, so what I like to say is that my biggest contribution to science, to physics, is not the rope model. I mean, I thought that was a good vision. I was very happy the day I discovered that. But this is my biggest contribution, the word object. I'm the first person to define the word object for physics. I'm not bragging here. I'm not showing off. I'm just saying it's a fact. Nobody in the last 10,000 years defined this word for us. Okay? And that's why, the mathematicians today who call themselves mathematical physicists, not one of them, not one can tell you what a thing is. And part of the reason that they can't tell you is that they've been using concepts, mathematical concepts, as physical objects for the last 10,000 years. And they never realize that if they're going to give an explanation of a mechanism, they absolutely need to introduce an object. And so we need to find out what an object is. And so what do they say? Well, it says that it's that which you can see or touch. And that's the main one that they use. It's defined that way in some dictionaries. Others have different, you'll find the Wikipedia says it's what is made of matter, meaning it's made of objects, because that's what matter is. So you have these different definitions, but both of them are irrational. Okay, both of them are irrational because an object is not that which is made of objects. You haven't defined anything, and you can't use the see touch. Imagine, a single object in the universe. There's a single object in the universe. What do you want? Sphere? Okay, we'll put a sphere there. Okay, that's the only thing God created. so far. He's going to create some more stuff, but the first thing he created was a sphere. Okay, so you have the sphere. God's out. He went back into the genie bottle. And so now you have a single object, and it's a sphere. So you can't see or touch it because you're not there. There's nothing there except a sphere in the universe. And so is that an object or not? I mean, do we need something else there? Do we need an object to hit it, to touch it, to see it? Do we need eyes? Do we need hands? Or is that sphere an object standing all by itself in the universe? And in fact, that's the way we do have to present objects in physics. A single object made of a single piece. All objects are made of a single piece. Tables, chairs, any word you can think of, the dog, the tree, the rock, they're all made of a single piece. Because all you're doing is pointing and saying rock. Okay? Rock gives no hint, the word rock gives no hint that it's made of many things. All you have is the word rock. And now the ET has learned the word rock. Okay, rock, I see. That's the word that you're using to designate that thing. So far seems to be made of a single piece. Okay? And one of the things that creeped into the word object, which has messed us for 10,000 years again, primarily from those people who call themselves philosophers, it's that they think that it's anything that can be used as subject of a sentence, anything that is a noun, is a thing. It's an object or whatever. And that's not true. The word motion is a noun in ordinary speech. It's a verb in physics. You can't use the word motion as a thing. So you can't just translate and automatically, indiscriminately, move the words from ordinary speech into physics. You have to look and say, well, what does this word represent? And that's part of the problem with that, as we'll see in a minute. And we have all these religions that came up, the traditional religions, and because they couldn't see and touch the mediators, they created all these angels and spirits and ghosts. They had all these words which they introduced because they said, well, God must be acting here, must have sent an angel or the spirit or whatever. So we invented all these phantoms. And that's in religion. Traditional religion, a lot of people still believe a lot of that, Then you had the Greeks, and they invented something even worse, the zero-dimensional 1D objects. You have the point and the line especially, right? Are those objects? Are those things? 0D point, a 1D line? Is that a thing? Is it a concept? What is a 0D or a 1D thingy? We need to figure that out. And again, the Greeks invented that. And then the mathematicians of today, they invented concepts as objects, field and energy and mass. They treat them as physical objects. They bend the time. And what's worse is that they have this four-dimensional space-time. They say it's an object, a mathematical object, I guess they'll call it. Is it an object? Is it a thing? Is there such a thing as space-time? And no, it's an abstract concept, and it's a mathematical concept. They're talking about number lines, okay? So, four-dimensional whatever, it's really four-number-lined whatever. That's what it is. It's not an object, it's not a thing. And I think this is what prevented us from understanding the word object, a thing. And because we don't have a word thing, we don't have explanations for causes and mechanism. So don't be surprised if, a mathematical physicist cannot explain to you, a mechanism, a cause for gravity or for light or the atom or whatever. Why? Because they're not using objects, they're using concepts. And they're introducing them into mathematical physics, meaning into science, meaning to the public, because that's how it goes. You have all these translators, these magazines that bring down the math and put it, serve it in a gold platter to the public. And the public just says, well, I don't know anything about that. It looks fine to me. If that's what the mathematicians have come up with, I guess they're smart enough, they should know. And so they swallow this stuff because it comes through authority, okay? So here's the big statement from me. Scientific definition of the word object destroys all religions. Takes 2 years for a person to understand what the word object means. And a lot of people skip that step and they say, no, I want to go directly to college physics. I don't want to do kindergarten physics. And they don't understand that until you master the word object, and you can't do physics. They don't understand that. And, it turns out that for the last 16, 17 years, I received all kinds of debates on the word object where people criticize, say, what about this? What about that? So we know the word object very, 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 very well. Okay, we're experts on the word object. When all these people come with ether and with plasma and with waves and fields and energy, we give them the run for their money. Okay, we show them that they don't understand kindergarten physics because they never went through kindergarten physics. They think, well, that's semantics, that's just ontology. What is that, philosophy? No, it's called the foundations of physics. Foundations of physics. You need objects to do physics. You better know what an object is. You cannot use the word plasma as a thing. It's not a thing. Neither is ether a thing. And all these dissidents who hate the establishment, they come with all these words. And and they don't realize that those words were put into their heads, into their mouths by the mathematicians who created those words to begin with. Okay? So they're using the language of the mathematicians to make their cases, and they're against the mathematicians. And so what we do here, we show them that we ask them kind of nicely, we use the word idiot. Idiot is a person who has big ideas, idiot. Normal people have ideas, rational people have ideas, these people have idiots, big ideas. And we show them that the reason they're idiots is that what they've been doing is using the language of the mathematicians who they criticize, put those words in their mouths. They can't. They have to get rid of all the language of mathematical physics. All of it, completely. Erase it completely, because all of it is irrational, and the problem is language. Till you realize that, you don't understand what's going on in the world today, so-called physics, science, mathematical physics. You need to get rid of all the language that the mathematicians created, because what these people are looking for are explanations, mechanisms, causes. And they're using the words that the mathematicians put in their mouth. That's what's happening. Okay, so where do we start? Well, last week I showed this, the map of the world, how science progressed from 3000 BC, and those numbers are quite arbitrary, by the way. And we ended up in Greece about 800 BC, before Christ, right? And that's when the Greeks kind of formalized a lot of the concepts that we had over the centuries before they came around. Okay, they formalized it. They started doing a little more work on how to present this in an organized way. Okay, and so they started with geometry, and geometry was really the first, you could say, the first attempt at doing mathematical physics. The physics part was the measurement, the experiment, the land that you measured. And the mathematics, math phys, right? The mathematical part was the numbers, the relations. Okay, they created some standards. They said, oh, this angle is 90 degrees, and it's got a line here, a line there. They measured the lines. They started figuring out all these relations. And so we have two things. We have the mathematics and the physics of it. And it turns out that you can't put them together. Geometry is an irrational religion. Geometry has nothing that you can really sink your teeth in physics. Okay, it's pure math. It's pure relations, but they're using geometric so-called figures, right, to apply this math to. Okay, so they apply it to triangles, circles, spheres, cubes, whatever, and you're going to look at all these relations. But it's the relationships here that form the basis of geometry, not the thing itself. People don't always understand that. And so here we have a definition of geometry, the first religion of mathematical physics, the first branch, I guess you could say. Geometry, what is it? Land measurement. Why? They needed to measure the land to be able to put buildings and so on. So they started measuring and looking at orientation, how something compared with the sun or with the moon or with whatever, right? A branch of mathematics concerned with properties of space, such as distance, shape, size, and relative position of figures. Yeah, it's about figures. But as we will find out, Lots of these, in fact, none of them are figures, okay? Because it's not the figure that ends up being part of geometry. It's the relations, the mathematical relations, which is part of geometry. None of them have to do with figures. They have to do with volumes, okay? And so we have to understand that. It's not about figures, but that's what geometry was supposed to be about. Okay, so here we have the AI, and we ask them, what about Aristotle? He came up with all this stuff about, the geometric relations and so on. And here it is. He said the following. This is what he thought an object was, a thing was, which is what they're going to be using for geometry. It says Aristotle had multiple definitions for the term object, including art, in art, in perception, and in general. Okay, and there you see, what was he thinking? He was thinking that a person, an event, or an inanimate object were objects. Okay? An event is an object, a thing. Maybe a person is, maybe an inanimate object, maybe, but not an event. And what was it all about? Well, it was all about perception. There you see it. Aristotle divided objects of perception, and he had colors, sounds, and flavors, shapes, sizes, and movements, and whatever you perceived. And again, in general, that's what he came up with. He said it's got to do with perception, with our senses, with what you can touch or see specifically. Okay, so this is where we started, and he had the wrong notion, an irrational notion of what an object is. Okay, no, an object is not what you can see or touch, but this is where they formalized it in the Greeks and said, look, this is an object, it's what you can see or touch. And we just sped along, and since then been doing see and touch. So you ask anyone on the street, what's an object? That's what you can see or touch. And because you can't see the mediator of gravity, there's nothing there. Because you can't see the mediator of light, there's nothing there. And you have entanglement, one particle affects the other one, you can't see or touch whatever in between, so there's nothing there. And then they worry about, relations. Was it instantaneous? Was there an immediate transmission of information? They get all this nonsense that's got nothing to do with physics. Okay, so here we have another fellow. He tried to do a little better about 100 years later, and his name was Euclid. And he has these two definitions, which are maybe the closest ones to the shape definition that I have, okay? And it says, a boundary is that which is an extremity of anything. And then definition 14 says, a figure is that which is contained by any boundary or boundaries. So he kind of went in circles with these two definitions, because he's saying a boundary is what covers an object, and an object is what's covered by a boundary. Okay? But that's not the problem. That's not the problem. He was close, not quite. He tried, okay? The problem is that no one ever used that definition. No one used that definition at all to this day. Okay, no one uses that definition. The definition is that which you can see or touch, that's one, and the other one is that which is made of matter. But none of these two definitions have ever been used. They just put them, Euclid put them there, everybody said, okay, I understand, which they didn't, because it's circular, right? But even if we could understand them as being, something related to shape, it was never used. The notion of object, meaning shape, has never been used. And again, it hasn't been used because the mathematicians have no use for objects, for shapes. Okay, that's art, or who knows what it is, Okay, and so what did we end up with? Well, we end up, because of the Greeks, right? Because of Euclid. And here you end up with, I asked the AI, again, R2D2 was around there, I asked them, so geometry is the study of property, la, 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 la. It's all about figures in geometry. But I like what the AI told me, and this, again, has to do with the mathematicians feeding the ChatGPTs and all these bots that we have out there. It says there are two main types of figures in geometry: two-dimensional, flat or plane, right, figures; three-dimensional figures like solids, right, that have, they said, depth, volume, and thickness. None of the three are dimensions, okay? But then it goes into and says, it gives two examples. So some basic geometric figures, right, uses the word figures, include points, have no width, length, or depth, and lines which extend infinitely in one dimension. I've never seen one-dimensional anything or a zero-dimensional, because point has no length, width, or height. So we have nothing in front of us. So what's the figure that they're talking about? How come these are the figures that are the building blocks of geometry today? Okay, and again, they're not talking about figures. When they talk about points, they're talking about locations. But they don't use the word location, because if they did, it would be a qualitative concept, first of all, and second, they would not be able to put it in any equation. It's a qualitative concept. And so, you can't say, we're going to build a cube with locations. We're going to build, a circle with locations. No, you can't do that, because people say, what do you mean with locate? You're going to build a figure with locations? And that's when it becomes obvious that, what they're doing is talking about concepts and not about geometric figures. And the same with a line. The line is infinite. That means it's not, if it's infinite, it means it's not an object, because an object is that which has shape. And whatever object is infinite is not an object, period. Because it doesn't have shape. It doesn't meet the definition of the word object. And if it's one-dimensional, well, you don't have nothing in front of you. That's what it is. And I like the statement that the bot told me at the end. It says, geometry is important because it helps us understand the physical world. Yeah, sure. If you can make sense of it, yeah, maybe. No, it doesn't. Geometry does not help us understand. It just describes what relations of volumes. That's all it does. Okay, we're not talking about geometry. We're talking about volumes. And here's a corollary you can get from good old Euclid, and that's that he's got. Let me make this smaller. There it is. And Euclid defined in his book 1 a semicircle is the figure contained by the diameter and the circumference cut off by it. Okay, so we have a semicircle. You'll see it here in the center. There it is. That's a semicircle, right? And what he does in book 11, definition 14, he says, when a semicircle with a fixed diameter is carried around and restored again to the same position from which it began to be moved, the figure so comprehended is a sphere. So he's building the sphere with movement. Okay, he's taking something, twirling it around and saying, look, that's a sphere. It doesn't look like a sphere. It looks like a line to me, right in the center, maybe the green part there, the thick green line. That's certainly not a sphere. And is a sphere something that rotates? Is that what it is? But this is how Euclid defined it, and he essentially built a sphere, which is supposed to be a figure, a static figure, without any motion, and he's building it with motion. So this is the problem. This is the type of irrationality that entered mathematical physics, geometry. They built everything with motion. Okay, so what is a circle? Well, they have all these rays, Euclid, all these rays to every point on the circumference. And what's the problem with that? Well, the problem with that is that there are infinite points in a line, because the point is a location. It's not a thing. It's not a dot. It's not a 2D or 3D dot. 2D point is a location. And you can put gazillions of locations between any two locations in math, because they're talking about numbers. And, you can divide the number 1 as much as you want. Infinitely, as they say. So the problem with Euclid's circle, that it's still being built. They're still building the circle, his circle, because there's so many points. He's got to draw all these rays from the radius to the edge, and on and on and on and on. And today they have a similar definition where they have all these points around, and they say that's a circumference that serves as the boundary, right, of a circle. But again, they have gazillions of points, and whenever you have 2 points, just put another one in between, and you'll never end, because they're talking about numbers. They're not talking about locations. Okay, So yeah, this is the kind of irrationality with which we started and we ended. We still have this. And one fellow says, one visitor here to the site, he says, motion is a property of matter. It needs motion to maintain form. That's what he said. This is what he was taught, or this is what I guess he came up with. I don't know. But this is what these people think. They don't have the ability to reason these things out. So they say, like water, which takes the shape of the container. Huh? Water takes the shape of a container? I don't think so. Where did he get that? Apparently he's still on Earth. He should fly with me to space. And there you see the astronaut. He had a balloon, and it had water in it. So he pops the balloon, and this blob is out there. It still hasn't disintegrated and turned into a little piece. He's got this single blob. And I take a snapshot of that. You can see there's the Earth and the moon in the background. Astronaut's flying on his flying saucer, whatever that is. And he pops the balloon. Here, this blob. I take a snapshot of it. Do you see any motion there? Do you see any container there? Where's the container? It's in space. Space is nothing. So there's no container holding the blob together. It's just a single blob. It's not moving as far as I know. I mean, maybe I have astigmatism. I don't know, but I don't see it moving. So I don't know what he's talking about. What he's talking about, container and motion, they feed nonsense into these people's minds, okay? And it says the fundamental substance takes the shape of its reciprocal momentums, which act like a container. Whatever. Water doesn't have shape. Well, it looks like it does have shape. I see shape there. Am I the only guy seeing the shape of water there? Okay, that's water. So I don't know what he's talking about. No, water does have shape. And it's not a question, what is the shape of water? Okay, the question is, does water have shape? Okay, so don't ask me, what is the shape of energy? No, does energy have shape? That's the question. It's a yes or no type of answer. That has shape, as far as I know. Correct me if I'm wrong, okay? Yeah, that does have shape. And just in case, we're going to put it in the Universal movie to make sure that, I'm still not drunk today, okay? There's the Universal movie, okay? Single frame, and we have the astronaut there with a balloon, pop balloon, and the water molecule, or the water blob, right? And as you can see, it fits into a single frame of the Universal movie. So there is no motion in a single frame of the Universal movie. All atoms in the universe are just at a given location from all others. That's all we see in a single frame of the Universal movie. And as you can see, it doesn't move. I would have to have two frames for the blob to move, to change form or whatever. Right now it has form and it hasn't changed, as far as I know. Okay, so please can let me know if it moves, if I've got something wrong with my eyes. I need to see an ophthalmologist maybe. Okay, is a cube, a thing? Well, here, I don't see it moving. Do you see it moving? Let me look. Doesn't look like it's moving at all to me, okay? And again, we put it in the Universal movie, and we see that it doesn't move. It can fit into a single frame of the Universal movie. So I don't know what this fellow is saying, that form requires motion. There's no motion there, and as far as I know, that has shape, form, whatever you want to call it. Those are synonyms in science, in physics. Okay, so much there. How about air? I mean, a lot of people get confused with air. I say air is an object, a thing. They say, you're crazy, Bill. Air is not an object, not a thing. Well, hopefully anything made out of atoms is a thing. Concepts are not made out of atoms. As far as I know, conscience is not made out of atoms. Love is not made out of atoms. Information, not made out of atoms. Because if it were made out of atoms, we could illustrate and say, okay, it looks more or less like this. You can't do that with a concept. Intelligence, what is intelligence made of? Atoms? No, intelligence is a concept. Love is a concept, and so on. Energy is a concept. You can't represent them with, an image, because whatever you're doing wrong. It's irrational what you're doing. You're representing a concept with an object, and that's outlawed in physics. You can't do that. Okay, you got to put an object and call it an object. Okay, like the rope, for example. Rope is an object. Go to the hardware store, ask for a 2-strand rope, they'll give you, what I always show. And that's an object. Call it a rope. Everybody can point to it, knows what I'm talking about. That's the shape of light according to us, okay, of the mediator of light. How about air? Well, okay, let's see. Here's air, okay. Does air have shape? Yeah, by the way, it's similar to the astronaut with popping the balloon. If he had air in the balloon, there would be a blob of air, all the atoms coming out, and you look at that whole aggregate, and what you see is a blob, and say, okay, that has shape, the whole blob, right? Then it disperses, keeps moving, changes form, right? But any snapshot that I take of those atoms, it had better had form, right? If you color coded, you could see it. Okay, so here's the air. Okay, and there you see air. That's what air looks like here on Earth, at least, right? And people say, "Oh, Bill, but you need the Earth. See, without the Earth, oh, I'm sorry. So I should remove the Earth. Let's remove the Earth so that people see only air. There it is. Got it? That's what air looks like. It looks like a ring. Really, it's spherical, so it's like a shell around the Earth. That's what air looks like. So air does have shape, hopefully. Okay, so people who say, "Oh, Bill, but I got you. Air doesn't have shape." There it is. Do you see a shape there or not? It's that ring thingy. I can only put it in 2D. Okay, so yeah, air has shape. Water has shape. Everything made out of atoms had better have shape. Okay. In fact, kindergartners know that because when they're drawing some landscape or whatever, they usually paint the air kind of bluish, light blue. And teacher asks, "What's that?" Says, "That's the air." Well, how come you could paint the air? How come you gave it a color if air is not a thing? I can't color love. What am I going to put for love? A heart? What do I put for a point? A dot? Like to do in geometry. Okay, this same fellow says, everything other than the object itself is an abstraction of the object. An abstraction of an object. I don't know what he's talking about. You can only abstract it but never truly represent it. Because the only thing that can truly represent something or some verb is itself. Is that so? Uh-huh. Well, let's find out. Here's the Klingon. He comes to visit us from Klingon land. Okay, he's in another world. Comes to visit, and we try to show him we try to teach him our language. Okay, that's what we try to do. And so here we have good old Uncle Sam, right? And he's going to talk to the Klingon and says, "Look, see what I'm pointing to?" Say, "Yeah." Table. Just one word. Okay. As you can see, there's no adjective in front of table. He didn't say that's the brown table, the green table, the big table, the small table. He just said table. No adjectives. There's no such thing as a dead cat in science, in physics, okay? Or live cat for that matter. There's only a thing called a cat. Okay, we don't put adjectives in front of the nouns, in front of the object when we present it to the jury, in the conference. Okay, say rope, tree, rock, one word, right? That's the beautiful rock. That's the ugly rock. No, none of that. We don't care about adjectives. And so people start asking stupid questions like, what is it made of? Who made it? How fast does it move? Where is it? How come I can't touch it? Does it exist? Table. It's that which has shape right there, right? That's called table. It's made out of a single piece. Yeah, but it's got 2 legs. It's made out of a single piece. The word table is a single piece. We don't begin to divide it and chop it up into little parts and say, well, it's made out of atoms and it's made out of molecules. It's got 2 legs and a... No. We just say table. That's how you present an object in physics. Made out of a single piece. We're not saying what it's made out of. We're not even relating to that. So you can't ask a million questions. Can you touch it? Can you not touch it? And this guy says, oh, but that's an abstract table. No. There's no adjectives in front of objects. So it's not an abstract or a real table. That's the word table. That's what a table is, what I point to. That's what I'm going to use in my theory to explain something. So I point to table, and then I use it. Okay, that's the way it works in science. Okay, you can't say, oh, but that's an abstract one. I wanted a real one. The word table, when you look it up even in the dictionary, it doesn't say, oh, some tables are abstract and the other ones are real. No, it doesn't work that way. Table is table, table. Here in the land of the Klingons, it's always table. Table is that thing that I'm pointing to. What's it used for? I don't know. Maybe the Klingon sits on tables, for all I know. We don't care. Okay? That's what a table is. Well, that's what the word table represents. I don't care if it's abstract or real. And just in case, we put it in the Universal movie. Okay, you can see the table stands alone. There's no motion. Doesn't change its form. Okay, there it is. Table. Very simple. Every atom in the universe is at a given distance from it, and that's important too because they say, well, well, I'm going to get into that in a minute now. Let me hold that thought. Here goes. Same fellow. He says the following. He says, I don't think plasma should be called a state of matter. State of matter. The mainstream say the sun is plasma. But what they mean is that it is gaseous plasma. Dr. Robichaud says it's liquid plasma. Well, first of all, Dr. Robichaud is not a scientist, okay? He's not a scientist because he's using the words that they shoved up his nose hole in high school and college. And those words come from the mathematical establishment. So he's still using the ancient language of mathematical physics, which is plasma, wave, field. He's using all these words that they fed him throughout his schooling. So you can't use those. You got to get rid of all of them completely. We have to erase all the language of mathematical physics, okay? Because none of them serve to explain how this universe works. So if you're wondering why they can't explain it, because they don't have the right language. It's a question of language. Language is absolutely important. So what is this plasma thingy, okay, that everybody talks about? I've never seen, I've seen blood plasma, that kind of stuff, but never seen this kind of plasma. But here it is. Plasma, wave, field, shadow, those are all concepts, okay? Does shadow have shape? People say, oh, shadow has shape. Well, not really. You take the box, you put it in front of the sun or the tree, maybe you put it out there and it has a shadow. You say, the tree has shadow, the tree has shape, and the shadow has shape. But as soon as you take the tree into outer space, shadow disappears. Where'd it go? It doesn't have shape because it's not a thing to begin with. So you can't talk about a nothing that has shape, a concept. Shadow is a concept, okay? But concepts don't have shape, and plasma is what? Ionized gas. Look at the meaning. What is the meaning of plasma? Ionized gas. And unfortunately, we put another adjective in front of the word gas. Gas is a thing. Okay? Air is one type of gas. Okay, you can say that's gas. And you see a blob of something. Let's assume some gas escaped from a pipe or whatever, and it's color-coded or it's black or whatever, smoke of some kind. You say, okay, that's gas. When you say gas in that context, that is a thing because it has shape. So you're saying gas. You could have called it air, or you could have called it, some other gas that you can think of, doesn't matter. But the point is, if it has shape, because all these atoms are together and you name that gas, you could name it X if you want, that's a thing because it has shape. Okay, and plasma is a dynamic concept because it's ionized. You can't take a snapshot of plasma. And here, let me prove that to you. Proof, evidence. Okay, let me convince you. Recruit you. Okay, here it is. There you have, hold it. Let me put this right. Give me a second here. Here it goes. There you have it. Okay, you have a single frame in the Universal movie, and they're putting motion inside, the single frame where there should be no motion. So that's where the problem is. These people are treating plasma as a thing, meaning you can take a snapshot of it. And I try to take a snapshot, but these things are constantly moving because plasma is ionized, ED, right? Ionized gas. And so something's happening to the gas, and that's why plasma is not a thing. It's a process, okay? And, it takes, again, 10 years for all these people to go through all these little steps to show you what an object is, what a thing is. And this fellow says, he says the following. He says, which definition should I refer to? Did Kelvin or Newton define it? Who is out there acting as king of definitions? Who puts a standard? Well, the issue is that no one puts a standard. The way we do it in science, right? Not in religion. Religion, it's a question of people raise their hands, 50% plus one. That's the definition that everybody accepts because it was voted for. The majority voted for that definition. It's like voting for the flat earth society, 50% plus one, the world is flat, period. We're done. And this is more or less the same thing. No, that's not the way we do it in science. In science, you have to defend your definition. And people who have a different religion say, I don't like your definition. Good. Bring your definition. Let's compare notes. You criticize mine, I criticize yours. And let's find out where we reach with that. Let's see if you can defend your definition. And if it's painfully obvious that you have an irrational definition, some kind of contradiction, right? Then your definition has to be thrown out because you're not going to be able to use it in your theory. I'm going to be able to tear apart your theory because you started out with a wrong definition, an irrational definition, not a wrong one. Wrong is my opinion, but irrational is objective. We have objective standards for irrationality. Okay, another fella comes over in a similar vein, here it is. You criticize the meanings cataloged in the dictionaries. Absolutely. Not a single definition of the ordinary dictionary survives into science because no one's ever learned how to define words, especially the word object, and the second word exist. Neither of those two words have ever been defined. And yes, the biggest problem in science is language, definitions. People don't understand it. They say, well, that's a semantic argument. No, it's laying the foundations of physics. You need to have definitions before you start to give me your theory. Otherwise, we can't follow you. And if you have a contradiction in your definition, as we will see in a second from the same fellow, then we don't know what you're talking about because you have these contradictions. Which definition are you referring to? Which notion? Okay. No one ever learned how to define words scientifically, rationally. Consistent, you can use them consistently, right? All definitions from ordinary dictionaries need to be revised before introducing them into physics. And there you have some examples. Object, field, energy, mass, time, plasma, all have irrational definitions. So if you don't know what an object is, if you don't know what plasma is, you don't know what ether is, then you cannot give your presentation. That's how simple it is. Okay, so this Falcon gives us an example, parallel to what we're talking about, definitions, right? And he says the word state in the dictionary, condition, way of being. Okay, and there's a contradiction right there and then, but it also indicates primarily, meaning there's more than one definition, right? Being still as opposed to motion or movement. Yeah, and this is the problem. The problem, if you define it as being, whatever, way of being, that's a dynamic concept. But if you define it as a state, which is a static concept, then you have a contradiction because either you can fit condition or state in a single frame as of the universal movie, or you need more than one frame. You can't have it both ways. And these people have it both ways. They say, well, it's got many notions, and he says that in fact here says in the dictionary there are examples of use of the word in combination with others. Okay, and so he continues. He says, for example, vibrational state means, right? Vibrational state. We already seem to have a contradiction because state falls into a single frame of the universal movie. Vibrational seems like requires more than one frame. So he says the condition of, again, a contradiction, oscillatory movement. And so oscillatory, it's a condition of oscillatory. No, you can't have that. Either it's a condition, meaning state, or it's oscillatory and vibrational. So we have contradiction. Either we're talking about something in motion or something that fits in a single frame, a picture, an image, static image, right? And he said in linguistics it's called polysemy, the ability to have different meanings. In science, no, you can't have many meanings for a word. And this is the problem. These people have several meanings and you don't know which one they're referring to. And they introduce whichever one is more convenient for them during their presentation. And that's when they lose the audience because maybe you were thinking it's a static concept. Suddenly it morphs into a dynamic concept or vice versa. And so if condition is a way of being, that involves motion. We're talking being is always motion. If condition equals state, then we have a static concept. You cannot merge those two. Single frame in the universal movie in the case of static concept. And then the second problem he's got is irrational in science to have more than one definitions for a word. And this is where these people fail, because they don't realize that language is so important. And they just gloss over that and say, well, I looked it up in the dictionary. Throw your dictionary in the trash can. It's worthless in science. Not a single definition survives. If you're going to bring a word from ordinary speech into science, then you had better, and it's critical for your case, right? You had better define it in a way that it's crisp, okay, that we know exactly what you mean, right? Then we can follow your presentation. Okay, so what is the definition of object? There it is. We begin with the foundations of physics. That's what we do here. This is not semantics. This is not ontology. This is not philosophy. It's called laying the foundations of physics. And you need these things to give the foundations of physics, which is explanations of mechanisms, rational explanations. The golden principle, you can't do physics without an object. You absolutely need an object, okay? Because if there's no objects in the universe, nothing is happening. There's nothing to see, nothing to touch, see, or even to experiment or go to a lab and do something. No, you need objects. That's the first thing. So the first word you need to define in physics, in the foundations of physics, the word object. You need an object. What is object? That which has shape. Shape is a universal property of all objects, right? All objects have shape, right? I don't know an object that does not have shape, but you're welcome to correct me, right? Space is its opposite. If a thing is that which has shape, nothing is that which doesn't have shape. And that's what space is, nothing, okay? Doesn't have shape. So it's not infinite because only objects can be said to be infinite or finite, and hopefully all objects are finite. There's no such thing as an infinite object, and space is not infinite because space is not an object to begin with. So you cannot say it's infinite space. No, what are you saying? What are you talking about? What nonsense is coming out of your mouth? No, space is nothing. It's not nothing that which doesn't have shape. That's not the same thing as infinite object. Distance, separation between two objects. Location is the set of distances, right? One object to all the others, right? And that's one of the things about the word condition also, and that I should have mentioned earlier. But the issue is that people say, well, what do you mean by condition? Doesn't the condition change from one frame of the universal movie to another? You say, this is the condition in which I found the car after it crashed. So that's the condition. And they begin to describe it and say, well, it's got its front fender bended, right? The windshield's gone, the metal is crashed. No, that's not a condition. That's a condition in ordinary speech. How do we do it in science, in physics, right? Mother Nature knows what a condition is. Condition for her, for Father Universe, whoever you believe in, is every atom at a given location in the universe. And so we have the car, and as far as Mother Nature is concerned, every atom of that car, whether it's bent or not, or broken or without gas, every atom of that car, that's the condition that car is in. That fits in a single frame. It's just every atom at a given location from all others for the car. That's condition. That's a state. That's the state of that car as far as Mother Nature is concerned, which is what physics is concerned about. The atoms that make something up and the locations of those atoms. That's the state. That's the condition. Now, when you talk about describing a condition of a car, you're talking about ordinary speech. It has nothing to do with physics. Okay, and then you have location, set of distances. One atom to all the others exists. Physical presence, meaning object that has location, right? I'm an object, hopefully, when I'm not moving. There we go. I'm an object and I have location, right? You take a snapshot and give it to God, a three-dimensional picture. He can look in there and say, okay, Bill is there. He's an object. I see a shape. And every atom of his body is at a distance from every other atom, including from God. If God exists, right? If he wants to exist, he better have location. Better be an object first. Motion, two or more locations of an object, and a concept. What is a concept? A word that invokes or embodies two objects. Okay, you need two objects. Why? Because it's a relation between two objects that someone is establishing. That's what a concept is.